So before the breaks, we know that if you take acid plus base, you get salt and water. If you take acid plus metal, you get salt and hydrogen. You take acid plus acid oxide and metal oxide, you get salt and water. And you take alkali plus aluminium and a bit water, you get salt and H2. Now, we want to calculate how you do the neutralization. Like how many ml you are given acid and base. How you neutralize these two things. So we are going into calculation. Okay. All the calculations start from the mole, number of mole in the stoichiometric equation. Yeah. So the process is called titration. Okay, titration. Okay, what I mean by titration process? We take a known concentration. So concentration here, it can be big M, which is mole per liter. It can be mole per gram if you want, but normally it's mole per liter. Okay. Yeah. So this one already covered in your test one. So if you're given a known concentration and another one unknown concentration, you make these two, then you predict the results by using the four concepts that you learned previously. Acid plus base, what you get. Acid plus metal, what you get. Acid plus metal oxide, what you get. Acid alkali plus aluminium plus water, what you get. It's the same. So let's say you take HCl plus sodium hydroxide, which is HCl aqua plus NaOH, sodium hydroxide, NaOH. So acid plus alkali, you know you get salt and water. So you write water bracket liquid plus the salt. Salt, basically you take H, you know you become water, right? The input HCl, H will become water. Cl will combine with the Na, the alkali, the positive ion in front. So Cl will combine with Na. So you get NaCl. Again, it must be neutral ionic compound. If you don't know how to balance the electron valence, you only need to look at the periodic table and then you predict how to balance it. Okay. Octet rules apply. Octet rules means 8 electrons in the orbit. Okay, net ionic equation for this reaction will be, again, if you see the question asks you to give net ionic equation, basically it asks you the equation of water. It's also a bonus question. Either you know or you do not know. Okay, so this one you need to memorize. If the question asks you to give or write the net ionic equation for any reaction, it basically acid and base, you get water lah. So basically this will be the expected answer. Acid, you have H plus. Alkali, you have OH. Acid plus alkali, you get water. You need to write this one. H plus bracket aqua plus OH negative aqua, arrow, and then you get H2O bracket L, not aqua. This will be the careless mistakes, mostly in the test. Some of you write water bracket AQ. I'll give you wrong answer. It must be L, liquid. Because it's not solution. It's not a product of combination of something. It cannot be aqua, right? Okay. This is how you do it. Okay. This one is in the lab later on. You will do titration. So what you do is that you have a known amount of acid. You don't know how many you need to add alkali. So this one was given in the question, actually. So you know how many ml of acid you have. Again, by definition, acid, it means number of H plus in this case. Number of H plus in the equation will combine with how many mole of OH in the equation. So just now, in this equation, in the net ionic equation, 1 mole of H plus will combine with 1 mole of OH to form 1 mole of water. Okay. So the process will be OH negative plus H plus. If you drip it together, combine together, you get water. Okay. Then this color means that equivalence point means that you get the balance amount. Means the pH level here, water is pH 7, neutral. If you get pH less than 7 means acid, more than 7 means alkali or base. Equivalent point means chun is water. Okay, water of course plus salt lah. Plus salt, but this is only look at H plus and OH negative. Okay, the rest you read. So at equivalent point, so sometimes this is a long question, ask you to explain how you do the titration. So basically these few slides lah. So it asks you at equivalent point what actually happened. So it asks you how you know you have reached equivalent point. So this is the answer. At equivalent point, the point of titration when the number of mole of OH equal added means you are unknown, you don't know how many OH you have. This here you add number of OH here will balance the number of H here. If here in the question you have 4 mole, you need to add 4 mole. If here H plus in the question it gives you 5 mole, you need to add 5 mole of OH at equivalent point. Okay. Then once you get titration point, titration complete. Or the question sometimes will be tricky. Ask you how you know the titration process is complete. This is the answer. If the question asks you how you know titration process already completed, expected answer equivalent point. You need to answer, explain what is equivalent point. Keyword equivalent point, then explain means the number of mole of OH added equal to number of mole of H plus originally in the solution. Yeah, so this will be the way we ask you question. Either you know or you don't know. Usually this one will be 2 marks. Very direct question. We'll ask you how you know titration already completed. Okay, right. So again, in the lab, you need to also answer how you measure the equivalent point. How you know, right? So we use indicator, right? So indicator can be pH and so on. Yeah. So this indicator will change to pink when it reach equivalent points. Okay. So this one is in lab lah. In the lab, like how you know it is equivalent. You use indicator. It's a chemical that you can see color change. Okay. Okay. In most lab, titration means in the normal lab sheet experiment in your school. Usually, you're given an unknown reactant added to another one which is known solution. Okay. So let's try to solve. Let's try to solve how to reach equivalent point. Again, you need to understand what is equivalent point. Means number of mole of OH will equal to number of H plus. H plus plus OH negative equal to water, H2O. It must be balanced. Okay, so this will be the kind of question you see in your test 2 or final exam. So in a titration, you see titration already means acid plus base. Titration means you take acid plus alkali, you balance it, titration. So titration, you're given a volume of something, of acid, of unknown concentration. Okay, so maybe I erase something on the whiteboard. Sometimes it's useful to draw on the question. So you are given HCl 1.0 ml. Okay, so for the test 2 or final exam, please give minimum 2 decimal place, or two meaningful numbers. If you have 0.00 something, give 2 meaningful number or significant number. Okay, this one is unknown. You don't know the concentration. You don't know the big M, right? You don't know. Or sometimes we represent concentration with the bracket. You don't know the bracket, that means the concentration. Requires, you need to add something here. Requires, you have 12.54 ml. Okay, V you have. Then you have Z, the concentration, I use bracket, 0.10 m, 00 m. Okay. Okay. So what is M again? M is mole per liter or mole per volume. Okay. This is NaOH. Okay. In test 1, in our discussion, I already tell you, in the chemical 2 question, you don't know what to do. You calculate the molecular weight. Okay. If you really don't know what to do, you calculate molecular weight. For example, you calculate HCl equal to H bracket plus bracket Cl. You go to the periodic table. Calculate how many gram per mole. Okay, this one you refer to periodic table. Give 2 significant figure, up to 2 significant figure. Okay, same, you do for NaOH. You go to periodic table, calculate bracket Na plus bracket OH. O plus H. You get how many gram per mole? Okay, then you link the big M with the molecular weight. Okay, so here, if you know the gram, you know how many gram or how many ml, you can calculate how many mole. Okay, so it asks you concentration of unknown to find this one. And it asks you reach equivalent point. You need to give definition of equivalent point. So after you write all this, you write equivalent point is what? Equivalent point is blah, blah, blah. Equivalent point is when the concentration of OH negative equal to concentration of H plus. Okay. Okay, in short, I've just used bracket now. OH negative concentration equal to H plus. So if you look at my slides, you see how we solve. Okay. First, you write the equation first, skeletal equation. You know that you're given HCl, you're given NaOH. So HCl, again, now memorize three types of acid, three types of alkali, common one. So when in this question you see HCl is an acid. So in your mind, you see acid plus alkali. You write the equation, acid plus base equals salt and water. This is the next steps. Then you write this one. HCl bracket aqua plus NaOH aqua, get water bracket liquid, not aqua, liquid plus the salt is NaCl. Check whether balance or not. Usually not balanced one, the first skeleton. Okay, so on the left you see 1H, on the right you see 2H. So the most easiest one is to increase 1Cl2, 1HCl into 2HCl. Okay, balance the equation. First you write skeleton, then you write balance the equation. Okay, I assume you already know how to balance. So it should be 2HCl then how many NaOH? 1. Then should be balanced. Okay. I think the equation is not balanced. This one is just a sketching at the back. We'll go through one by one, right? First, you need to change after you get the equation. Second, change all the unit into unit SI, which is in liter. Change ml into all the ml into liter, because what is capital M? Capital M is mole per liter. Change the unit all into liter. 1 liter equal to 1000 ml. Okay, milli is 10 power negative 3. Okay, then find how many more and find how many more of HCl. Yeah, then after that you balance the whole thing. He asks you concentration. At the end, you need to answer in mole per liter. He asks you concentration, capital N. Yeah. Okay. So in this relationship, does it balance? I don't think it's balanced. It's balanced, right? Because on the right you got 2H. So you don't need to add, no need to become H2HCl, because on the left you already have 2H already. Okay. So here you know that 1 mole of HCl plus 1 mole of NaOH, you'll get 1 mole of water and 1 mole of NaCl. This only apply in tutorial. In test, you won't get perfect equation like this. You will have some numbers in front of the element. Okay, here you know that because the question asks you acid plus base, so you find the ratio 1 acid plus 1 mole of acid plus 1 mole of alkali. So this one you write inside your answer, you write 1 mole HCl double dot 1 mole NaCl. This will be the mole or the balance according to the stoichiometric equation. Okay. Then to avoid your careless mistake, you write the capital M morality. You write capital M equal to mole per liquid liter. Right somewhere inside your answer. Okay. This is just to remind yourself. Okay. So once you know, you convert. This is your known value for NaOH, right? So 12.54 ml will equal to 0.0125 liter. You change the unit ml into liter first. You will get 0.0125 liter of NaOH. Change to liter. After that, from liter, you find how many mole you have. Inside this 12.54 ml, inside there got how many mole? Basically, if you understand what is capital M is mole per liter. If you take capital M multiply by the volume, you get more. Okay. So my answer in the slide here might not be what I call, in the test you need to tell me you need to tell me what are you trying to calculate. For example, 12.54 ml equal to X liter. Then you do conversion. X liter equal 12.54 ml divided by 1000 ml per liter. Then you get 0.01254 liter NaOH. You need to tell me what is this, NaOH. This is NaOH. Second steps, you need to tell me calculate number of mole. So here you put this on this calculation. You need to tell me what actually you're trying to do. Okay? Don't just straight away jump in like what I show you on the slide here. You need to tell me what actually you're trying to solve. This one okay? So why I take 0.12 multiplied by 0.1 mole divided by 1 liter. This is from the capital M here. Okay, you convert the capital M into mole per liter. Okay. Then you cancel the liter in the equation. Test 2 and final exam, I will check how you cancel your unit. So don't just give me numbers. You need to give me unit and then show me how you cancel out the unit. So at the end, you need to show me when you cancel, then it's very logic, you get more something. Okay, start from test 2 or final exam. If you give me numbers without unit, I'll put a question mark. What you're trying to calculate, I don't know. Okay. Okay. You can use 0.00 something, or you can use index, depends on your preference. In chemical 2, I don't really very particular in the format of your answer, as long as you get the answer that the value that I'm looking for. Right? So from there, so from there, the first step, once you already know how many more NaOH you have, this is the number of mole you have. To titrate, to get equivalent point, you need the same mole of this one. You can skip these steps, actually. You can skip this line if you write this sentence. You write 1 mole of HCl, double dot, 1 mole of NaOH. Thus, you can write 3 dot there. 3 dot. Zero 0.1254 10 power negative 3 mole NaOH can dissolve or can neutralize 0.1254 10 power negative 3 mole. It means the same mole. Okay, you don't need to show these steps. If you write the 1 mole of acid equal to 1 mole of alkali, you don't need to write this one. So that I understand now, because it's 1 to 1. So very logic, you have the same mole of HCl. Okay, now you have mole already. The question asks you concentration. Don't stop here. Concentration is what? Mole per liter. You already have mole already. Put your number there. This is your mole. Liter is the container. V is given 0.0 0.0 ml. Convert this one into liter. So here, or by the side, you can write 1 ml, 10 ml equal to 0.01 liter. So here is 0.01 liter. Of course, on the top is mole. This is HCl. Plug in the calculator, you get the numbers. Yeah. The number is 0.125, capital M, molality of HCl. Okay. In the lab, it will not be so direct. In the lab, you need to find how many liter. So it will be the same equation, but something inside the equation will be missing, especially the volume. Yeah. In the lab setting, we will give you the molality. You need to find the how many liter you need to titrate. Just for your info, test 2 or final exam, you need to find the volume, like what you do in the lab. We give you the known capital M of 2 solution, acid and alkali. You campur, reach equivalent point. You need to tell me how many ml you need to add into to mix together the two. Yeah. Cannot? Can I? Move on. Okay. Let's see if you're able to understand. This one I go very fast. The same concept. You are given volume of something of unknown concentration. Requires volume is given to 2.87 of KOH solution to reach equivalent point. If you don't know, you just draw 2 beaker, 2 container. One is H2SO4. One is KOH. These two must be mixed. Then you know the volume. This one is 0.20 ml. V, this one you also know. KOH is V equal to 22.87 ml. First step is to write acid plus base equal to salt and water. If you really don't know how to answer, write, you see acid and base already, write acid plus base, get salt and water. Then balance the equation. Write the skeletal equation, H2SO4 plus KMO, you get salt and water. Water you know is H2O. Then you take the front acid combined with the alkali, the number 2, the OH negative. Okay. Once you do that one, you are given capital M here. Next steps, you convert all the ml into liter to avoid confusion. You see ml already, you move to liter. After that, give definition. What is capital M? Right, M equal to mole per liter. So here, you calculate, you write the equation first. Okay. It's just, yeah. So maybe I'll show you the steps. The step actually quite same lah. It's always go to the same way. First, you draw something on your answer. 2 container, acid plus alkali. Okay, acid, alkali, or base. You get salt and water. Then you do the skeletal equation. H2SO4 plus KOH. You get salt, you don't know. You continue. Water is H2O. Remember to put in the state. H2O, H2SO4 is aqua, AQ, KOH also AQ. Water is liquid, but you don't know the salt. Salt is okay. Salt is you take what you can see here. Like for example, H2. H you know that going to contribute to water, so remaining in SO4. SO4 is the second member of the first element. You will combine with the metal of the second element. In this case, is K. K will combine with SO4. OH will combine with H2 to get water. So here, maybe you balance this one first. So here got H2SO4 and KHO. Here got 3 to HO4. So maybe we increase the maybe we increase the KOH, right? Oxygen also got 2, right? If you calculate oxygen, oxygen got 4 plus 1 is 5. 5 oxygen, here only got 1, right? So you need to balance KSO4. So maybe you add in 2K here. So here will be 2. Then SO4 will be 8. So here will be 2 also. Then here will be 2H24, 4 plus 6. So this one is 3. Then oxygen got how many? 3, 11. 11. 8 plus 8, 8 plus 2, 10. 10, 10, 2. This one take time a bit to balance the equation. Okay, so this step I skip a bit. Once you balance, you'll get how many mole plus how many mole equal to how many mole? This one. So you get A and B. So you write A mole H2SO4 double dot B mole KOH. Okay. Then you know this one 22.87 ml with its V, and you know the molality with its 0.158 m. So what is m? M is mole per liter. You want to calculate this one, how many mole? Right? So here 0.158 mole. This one you can write equal to 0.158 mole per liter. Okay? Mole per liter. So you want to know how many mole? You want to know how many mole? So X mole of KOH will equal, you take this one, 0.158 mole per liter multiplied by the volume, this volume, in liter also. So this one is 0.02287. You shift 3 decimal to the front, become liter. You multiply, you get how many mole already? Then you compare with this one. Okay, so let's say I get X equal to C. I get C mole. I go back to here. Now I know C mole here. I don't know D. Right? This is the two linear equation. So to find D, I cross the equation. This one multiply this one multiply this one. I will get BD equal CA. I want to find D, right? So D equal to CA divided by B. I get the answer already. Okay, I get how many mole already. Question asks you concentration. You have how many mole? So still back to the mole, the capital M of this one. Capital M equal to how many mole per liter? Here already give you ml. Change this one to liter. So this one is 20 liter. So 0.02. Mole, you already find D here. Put the D here. Press calculator, you get the molality. Mole per liter. Yeah, so this is the logic how you do. Okay, so in the lab, how you design your experiment. In the lab, let's say you know M, you know this one. So you need to redesign your steps. Actually, is inside there. Something is missing. You just need to find the volume. Cannot. Okay. I use this one as example. This one. Because I see that you don't understand how to get volume. Right? Don't understand, right? Understand? Don't understand. Okay. I use this one. I use this one as an example. Because we already know the answer, right? So I reverse the question. Okay. You know titration, you are adding something to a beaker. Okay. It's either H or OH, lah, doesn't matter. You are adding two material here. Okay. Let's say you don't know how many liter you want to add to this known volume. Okay, I take this one. So let's say this is HCl. This is NaOH. This one you know. This one M. This one the capital M. You know 0.125 capital M. In the experiment, you can measure how many HCl you have. Right? In this case, I just copy there. 10 ml. But I convert this one into liter for my calculation. 0.01 liter. In experiment, everything changed into liter, then you convert into the apparatus. Let's say apparatus is ml, you convert liter into ml. For calculation, everything you go into liter. Okay, so this one you know. How many volume you know? V you know. Concentration you know. This one you know. You know the M. 0.1. The M you know. But you don't know the V. So how? First steps. You know that you know that you are adding HCl and NaOH. Write equation first. HCl plus NaOH. You predict the result. Acid plus base, you get salt and water. So if you don't know, just write water first. H2O. Okay. Salt is just a combination of these two. So H already become water already. Remaining Cl, you write Cl. Then you combine with the first one. Because OH already become water. So Na will form with Cl. So NaCl. So this is the equation in your stoichiometric equation. You check number of OH is balanced or not. We know that this is balanced. Okay, so here, from this equation, you know 1 mole HCl will neutralize 1 mole of NaOH. This is to reach equivalent point. Right? So we have this one already. Now, you know this one, right? You know molality. This is what you have. This is also what you have, but you don't know the volume. You start with what you know first. Here you know, ma? So you have 0.125 molality, capital M. What mean by M, capital M? You just convert this one, 0.125 mole per liter. Right? This is the solution, is capital M. But this solution was poured inside a volume. You know volume. This volume is 0.1 liter. So inside this liter, how many mole? This one, conversion only. Mean you take this one, you take M, multiply by volume, you get mole. Right? You take molality, multiply volume, you get how many mole? So here you have 0.125 mole divided by 1 liter, multiply 10 ml is 0.01 liter. So if you press calculator, this is 0.00125 mole. Right? Because this is divided by 100. So move 2 to the front. So you get 0.01 mole. This is the total mole you have inside this beaker. This is mole of HCl. Right? So back to here. This is from the equation. Then you write another one from the experiment. This is from experiment. You don't know how many mole. You don't know. HCl. Sorry. You know how many mole. You know. So you know, you write 0.00125 mole. You don't know how many mole NaOH, right? But from here, 1 to 1. So here, 0.0125. Here, the mole here is 0.00125 mole NaOH, right? So mean this one must be inside here. This whole set, when you pour from NaOH, you must use 0.00125 mole to neutralize 0.0125 here. Okay. Now, you already know you need this mole. You are given concentration already. You don't know how many volume. So you write mole equal to mole per liter. Or you really don't know, you can write a number in front with it 0.1 capital M equal 0.1 mole per liter, per 1 liter. Okay, now you know that you need to add this mole of NaOH. So how to get the liter? How to get the volume? This is mole per volume. So this one you know, right? This one you know. So you know 0, this one is, okay, here. You know this one, right? So this one is, for NaOH, you know 0.1 capital M. Right? You know, equal mole per liter. Let's say you remove this one. So if you want to look at only NaOH, you write 0.1 m equal 0.00125 mole. You don't know the volume. You don't know how many liter you need. Because you need to stay this one. So you move around. So how many liter? Question, liter of NaOH equal to 0.00125 divide by 0.1 m. This is mole. Capital M is liter per mole, mole per liter. You cancel the unit, you get liter. Right? So you press calculator, 0.0125 divided by 0.1. Basically, it's just move one digit to the back, 0.0125 liter. You need to add 0.0125 liter of NaOH to neutralize. But in the experiment, maybe you use ml. Convert this one into ml. So you need to add 12.5 ml of NaOH. How about that? So you see, at the end, we still get 12.5 something. This is the steps that you need to go through. Yeah, so just recap. So recap, So if you're given something that you know, let's say I just assume this one is A solution that you know, you will be given molality M, you'll be given the volume, these two will be given. You'll be given another solution B. Usually capital M will be given, volume you don't know. Okay, so how to solve? First steps, change ml to liter. Okay, so when you change all into liter, write second equation. First steps, change unit. Second step, write stoichiometric equation or balance equation. Stoichiometric equation means A plus B, you will get C plus D. In this case, acid plus alkali or base, you get water plus salt. Okay, acid is aqua, base is aqua, water is L, salt is aqua. Okay, balance. Okay, that's three. Balance the equation. Balance the equation means you will get A something in front of A plus small b C plus D. Those small a, b, c, d is mole. Number of mole. Okay, step number 4. You know that this is titration. Titration, you only focus on acid plus base. So what you do, you write A mole of A equal or double dot balance B mole of B. Make sense? Number 5. Convert the M capital M concentration that you know, into mole of something. This one you from the known container means the one that give you complete information. For example, in this one I write on the whiteboard is the solution A. You calculate solution A first. How many mole solution A you have? In this case, so how many mole of A you have? Once you have how many mole of A you have, go back to equation number 4 or step number 4. Find the how many you need to balance, equalize the A. Okay, so this one you convert capital M or M, okay, M, capital M equal to mole per liter. How to get more means you multiply this one equation, multiply equation with the V you know. You get how many more already. Reverse these steps for another unknown. Just reverse this step only. Reverse from here. Step 6. Go to what you know from A, B, for example. B, you are given M. Convert M into mole per liter. Okay. So you know how many B already. So calculate. Here, step number 6, you just put in together. A double dot B. And you know this one is, let's say it's a new, I put this one is X. You know the new X already. You don't know the Y. This one you don't know. This one you know already. Here you can calculate the X. Put in your X here, you can find Y. Why you find Y? Go to step number 7. Take Y, multiply by the B molality, this one. You get volume already. Okay, because Y is what? Y is liter. The molality is mole per liter. Liter cancel, you get more. Sorry. You divide. Okay, you divide by the mole. Okay, then you get volume. Who still don't understand what I'm talking about? These steps are. Okay. Okay, we go on until we stop at 1:30. Okay, continue. Okay, I go very fast. Now, we already done the how do you balance the acid already. 5.7, you need to identify whether it's a strong or weak acid and base. Again, we still use OH and H plus or H3O plus. Previous lecture, we know that H plus also equal to H3O plus. All right. How you know strong and weak? This is a keyword. Depend on how they ionize or dissociate in the aqueous solution. Means how they split themselves in the process. Okay. If they are strong, they are completely dissolved or ionize themselves. Ionize means HCl completely 100%, 1 mole will break into 1 mole of H plus 1 mole of Cl negative. You'll break 100%. Okay. So Chemical one, you will see individual arrow. So if you see or you use individual arrow means you are using strong acid. Okay. So this also explain in your answer, if you see strong acid, don't use reversible arrow. If the question mentioned you are given strong acid, it means your stoichiometric equation is single arrow. If you are given weak acid, then you can use reversible arrow. Means one to the left, one to the right. Okay. So here is H3 plus aqua, and not H plus, because in the acid you will see most of the component or concentration will be in H3O plus. Although H3O plus is equal to H plus. Okay, right. So this is just an illustration. If you put in HCl, they will break into H plus or H3O plus and Cl completely. Yeah. Okay. So if it's strong, means almost no intact HCl, means they break themselves into ion, 100%. I see if you understand this one or not. 1 molarity of HCl solution therefore has HO3 plus of 1 mole. Means inside there got 1 mole of, if you see here, you have HCl. Inside you only have 1 hydrogen, so 1 mole. Okay. So start from today, if you want to mention about concentration, if you want to calculate concentration in molality, you can straight away use bracket already. You don't need to write a long sentence. You just bracket that particular element you want to calculate equal to your calculation. So if I see your answer with bracket, it means concentration. Of course, when you back to chapter 1 or 2, if you use bracket, it means ion. In Levi structures or in resonance, it means structure. But in chapter 5, it means molality. Don't confuse between chapter. So yeah, so this will be some elaboration of what actually happened. Okay, another properties of acid, because strong acid can break into completely H plus and another ion, they are strong electrolyte. It means they can conduct electricity. Strong acid equal to strong electrolyte. So sometimes final exam question asks you giving the two process, then it asks you which one can conduct electricity. You ask you like, I will give you a beaker and two setup, and then I ask you which one will conduct electricity, which one will give you the light bulb will light on. Okay, or what do you predict from the experiment? If you use strong acid, you will see light bulb light up very bright, means it can conduct electricity. Yeah, so something like this. So this one you will see in the lab later. You need to explain what you observe, then you need to explain why the phenomenon is like this. So if you see lights up, it means that is a strong acid that you use. You're using strong acid. Okay. Explanation is there lah. So this one I skip. You read lah. Okay. Okay. This is also a trap in the exam or test. Sometimes I give you pure water. Pure water is not a good conductor because there are very little charged particle inside there. Pure water don't have ion inside. Pure water don't have ion inside. This is some electrified accident. Why accident can happen in the bathroom, especially if you have a plug inside the bathroom, and why the electricity can conduct, is because in the bathroom the water is not pure water. In the bathroom, it's not pure water. That's why it can conduct electricity. Yeah. Okay, so this is just a memorize for your info. These are some example of strong acid. You need to memorize at least 3 from here, right? The rest you read lah. Okay, because I won't ask you what is mono, what is poly. We don't go there. Huh? Okay, this is just for your info. Okay. Okay, weak acid. Just now, strong is 100%, is the opposite of the definition of strong. Okay, it means you add in, does not completely ionize. Just now, strong is completely ionized. And then the arrow change from single arrow into double arrow. This indicate you're using weak acid. Okay. This is some illustration. Illustration. Okay. Okay. And because they are weak, means they are not completely, does not completely ionize, means inside the solution there's lack of ion. So they are weak electrolyte. They are weak electrolyte. They still can conduct, but you see the light bulb inside this photo is not as light up as the strong acid. You can see some light up lah. Okay. These are some illustration. If you're given a diagram and ask you to guess which beaker is, which inside container is a strong acid, from here you know that this battery light up. This one, this side is strong acid. This is weak acid. This is neutral. Means no ion inside. Okay. So these are the comparison. If no ion, no conductivity. Got few ion, yes, will bright out. But if you have many ion, you will have brighter light in the bulb. Okay. So these are the, and just now we use the word electrolyte. Okay. So sometimes you need to use non-electrolyte, weak electrolyte, or strong electrolyte. Okay. Okay, strong acid. This one is about the degree. And we bring back the word conjugate acid, conjugate base. With this acid, it break away, it become alkali. It become another new member. It's called conjugate base. Right. So strong acid attraction of H plus and the element of negative is low. So resulting a complete ionization. This is about attraction. Attraction between H plus and the reactant element is strong because the both of them are not attracted to each other. That's why they can 100% ionize. If they are partially strong attraction, means they want to group together. If they want to group together, they can form compound. Reaction happen already. When reaction happen, there's no ion inside. The amount of ion inside the solution is become lesser and lesser. Because if you have weak acid, means they want to grab something to be together. Yeah. This one you read. This one you read. It's a concept of weak, strong acid. So memorize three from here. What are the example of weak acid and strong acid? Yeah. Acid weak, yeah? Okay. So just a quick quiz. Ask you to determine concentration, which is the bracket M, means mole per liter. So here, determine which one A, B, C, D, determine the H3 plus or the H positive inside the solution. This one, how many H plus you have? How many mole? Or how many capital M you have? You have one, right? So it's 1.5 ml. This one got many H lah here. You need to calculate lah. You need to write the, okay, here you got H and H3, you got 4, right? So you need to calculate lah. Okay, first one is 1.5 m, it's quite direct because they have one H. So second example is a weak acid, so it's partially ionized. Partially ionized, you cannot get the exact number, but it's going to less than 3 mole. This is how you answer for weak acid. If you're unable to calculate, you need to explain it in a certain way that you can know actually which direction, either more or less. So you can use this symbol, bracket, and then less than or 3 mole. So this one is a strong acid. Strong acid concentration will follow the front. Okay. Okay. Strong base idea is the same. I will just give you some time to read it through. It's the same things. It means if it's some strong base means completely dissolved, completely dissociated, right? So same lah. This one you read through. Weak, also same. Weak is partially. So partially. Identified by the this reversible symbol here, 2 arrow. Yeah, strong you only have one direction. Weak you have 2 direction. Okay. And you might ask, hey, Dr. Ang, what about the arrow? Either it's go to the top one is go to the left or to right. Actually, it doesn't matter. Okay, the arrowhead actually doesn't matter as long as it go 2 directions. Okay. The rest is red. Actually, it's the same. So these are the process, how it go through the ionization reaction. So this one also the same like acid just now. Ask you to guess what is the OH concentration based on the molecular molality. Okay, this one also give you the answer. Water. This one. Okay, so if you take water plus acid, water will become base. If you take alkali plus water, water will become acid. By using the definition of number 2, BL definition. Okay, why? If you write the equation, HCl will become H3O plus, like what we exercised this just now. Acid will become conjugate base, right? So base will become conjugate acid, same. So this is just to identify which one is acid, which one is base. No neutral one. In the chapter 5, nothing is neutral unless the product will be neutral. But the input, usually you need to identify either acid or base. Yeah. 1 more minute. Okay. So if you see water inside chapter 5 question, acid or base, is called amphoteric, means it can be base or it can switch. It can switch between acid and base. The process is called self-ionization. This one all you read lah. All you read. This one you see in the question, I'll give you all this number, so you don't need to memorize. Okay. Now we start with the first equation. To calculate the concentration, ion product constant for water, you need to calculate Kw. Kw given by, you take the bracket of the acid, means concentration of acid, plus concentration of alkali, you multiply the two value. This is M, capital M, molality, M. Mole per liter multiplied by mole per liter. Okay, so this one you'll be given, this number you'll be given in the question. For example, water at 25 degrees C is 10 power negative 7 M. So if at 25 degrees C for water, you take 10 power negative 7 multiplied by 10 power negative 7, you get 1 multiply 10 minus how many? This is algebra. This is normal algebra. Your mathematics teacher. 1, 10 minus 7 multiply 1, 10 multiply 7. What you get? 1, 10, how many? Multiply equal to plus lah. So minus 14. Okay. So here is a constant. Do not have any numbers. It's a constant. Okay. Now water, this number is the magic number. By default, you need to memorize this number. It won't be given in the test 2 or exam. This number you need to memorize. For water is 10 power negative 14 at 25 degrees C. This magic number you have to memorize for chemistry 2, test 2, and final exam. This value won't be given because you write Kw equal to 10 multiply 10 minus 14, you get 1 mark. This is where I give you 3 marks. That's why I don't give you the numbers. Okay. So if you if in the pure water or neutral solution, what I mean by neutral means acid and alkali is the same. So how you find? So if this one is the same, water is the same. So what you do, if it's the same, what you do, you take this number, square root it, because these are the same. These two values are the same. So what you do, you square root the Kw. Square root means this one divided by 2, you get 10 power negative 7 M. Yeah. Meaning if you are given any acid or alkali, you're given the K constant for that solution. You want to find is in neutral solution, you just square root it. Yeah, you just square root it. That's why this one number, 7, right? Magic number. This also represents the pH value that you see in your pH paper. You measured 7 means this 1.10 power negative 7 m for that solution. If you get 14, means very alkali. You move to this side already. If you get 1, means you get very acidic. Sorry, it depends on the number of H you have. The more H is more alkali. Sorry, the more H it will go to more alkali. Okay. Okay. This magic number always minus 14. Because if you calculate the pH table, it's from 1 to 14. Neutral in the center, 7. So maximum you can measure is 10 power negative 14. For Kw, maximum is 10 minus 14. So if you increase this one must reduce so that at the end you still get 14. Here, so after today, one magic number in your mind, Kw number maximum is 10 power negative 14, and it's a product of H plus and OH negative. It's a product of these two. If you're given 1, you can find another one. Because this constant value already given. You already know. Okay? For example, you are given H3 plus is 10 power negative 3. You can find how many OH you have. Okay, you just divide it. 14 minus 14 divide minus 3 means you plus. Minus 3 minus 11. Yeah. Remember this one, this Kw, constant value, 10 power negative 14. And it's a product. So this also some of the bonus marks. I think this one come out in your final exam. Or test 2, I forget it, but I'll give you hints later, right? Okay. In acidic solution, it will be more than 10 minus 7. In acidic, acidic means H plus a lot. So M value is big number. Okay. OH negative is less. So these two must be balanced. Okay. If acidic, H plus is high, OH is low. Total is 10 power negative 14. Okay. You need to sensitive a bit. What is high, what is low? Negative sign. Negative 6 is a big number compared to negative 7. Okay, something like that. So you need to sensitive a bit. Okay, the rest is just repeat what we say just now. Okay, if it's alkali, acid is low, OH is more. Okay, by using magic number 10 power negative 14. These are the chart, visualize chart. If your OH plus is high, means the negative number is low. It's very high, it moves toward acidic. And if it's OH a lot, means the number very high, so the negative number is very low. If you have big number of M, it go towards that direction. It must be different. In one of the attachment, I forgot where I put it already. Okay. Okay, by looking at this, you should be able to tell whether it's acid, base, or neutral. You see minus 7 is neutral. Minus 9, does it a big number or small number? I mean, you look at the scale. Maximum is minus 14. minus 7 is middle. Let's say I put the first one, minus 5. This one is H plus. Minus 5 is a big number. Huh? Minus 5 is a big number, so this first one is acid. Huh? This one, minus 9, less than 7. So H is less than 7. So H plus is less, so OH more. OH more is alkaline. You try to like imagine. Total, if you push all the way, total you can go is 14. It means 0 and 14. Try to push the two things. Okay. The answer is there, so you can read. Read. What else? So this one scale is based on a number. So we already cover. We cover. So this one also you refer. Like in the exam, in the test, you will be calculate the K value and the M value of H plus or OH negative. From there, you will need to refer to pH scale of this one. pH scale of this one. I will give you. You will see this chart in the exam. You tell me whether it's acid or base. Okay. The rest you read. No complicated things. This is just an illustration. Log. Okay, this is just a recap. What I mean by log? Log 10 is 1. Log 10 is 1. Log 2 is 2. Means if you log base 10, you just move the exponential to the front. Log 10 means 1. Okay, like this. So this to calculate the pH value. So nothing. So you just memorize this one. Careless mistakes is minus here. Most of the student will miss out minus in the test. It's negative sign because why? If you log something, it's 1/10 power negative something. Remember, it is 0 until negative 14. So you need to get a positive value. Yeah, so from there you find the number of value of pH. Okay, less than 7 acidic, more than 7 alkaline. Okay, the rest you read. The rest you read. It's just mathematics. The rest you read. Important is this equation. This one will have 1 mark. This one. Okay, the rest you read. This one also you go through. It's just mathematics steps to calculate log. This one I won't go through. This is just mathematics class. You read. If you have a question, you come and ask me. Okay. This got example. You can see this example. If you don't understand, you can come and ask me. The step is there already. Yeah. Okay. Important is this one. pH equal to minus OH3 plus. Then read the example. Another one is just now is H plus. This is OH. Same thing, but this one is for alkaline. Okay. Read the same, the slides, is always the same. This one you read. Okay. What is the difference in the question? How I ask you base or acid is this one. One is one is H3O plus, one is OH negative. The way you calculate still same. It's still using log. Minus log something. Okay. This one you go through. If you have question, come and ask me, or we can cover in next class. This one also you read, huh? Okay, this one I go very fast. This one is in your lab. What I mean by buffer? It means if it's acid, it will stay acid. If it's alkali, it will stay alkali. It means in layman term means if it's a boy, it will stay boy. If it's a female, then it will stay female. Okay. So if you ask an acid to act as alkali, you add alkali, it will still show acid. That is what I mean lah. These are the process. I'll skip lah. So means application of buffer means your blood actually circulating and balancing the blood pH. It always back to 7, around 7. Means blood is protein, you will create something lah to counterbalance the acid and alkali based on what you eat lah. Okay, this one you read lah. And do. Okay. This is important, these slides. Go home, read. 4 point only to summarize buffer. Buffer always resists pH change, means it will remain. What is this? If it's acid, it will stay acid. If it's alkali, it will stay alkali. Yeah, the rest is just elaborate what is buffer. Okay, in the lab, we will do experiment of this one. You add acid, it will still acid. You add alkali, it will still acid. You add acid to alkali, the alkali will still alkali. Okay, you will see this one in your test appendix. Okay, with this we conclude chapter 5. Okay, if you have any question, come and ask me. Okay, we dismiss our class here. See you next class, chapter 6.